Hi, everyone. Today, what we're going to talk about two special types of lines, parallel and coinciding lines. Okay. So this is a brief review. There were two special types of answers that we had when we actually solved the equations. This is going way back where we actually had one set of answers where we had all real numbers and another special answer, a special solution where we actually had the null set, no solutions. So this lesson is going to get you into why that actually does occur. Okay. So why do we have that? Well, it's because of these phenomena we have with parallel and coinciding lines. Okay. So here's my first line that I have, my first system, which is 2x plus 5y equals 11. So I'm just going to unhide that. And this is the line that I physically would graph if I were to put that in slope-intercept form, or if I were to just graph it using a table of values. Okay. Then I decided to graph a second line, 4x plus 10y equals 22. So if we were actually solving the system here and using linear combination method, what we would probably do is try to make either our x or y values the same. Okay. So if I look at my 2x and I ask myself, well, what times 2x could possibly give me 4x? I could multiply the entire system by 2. When I do that, though, what I actually end up getting is the exact same equation, 4x plus 10y equals 22. So if I were to subtract, because I'm trying to eliminate my x values there, if I were to subtract these guys, what I would end up with in the very end, if I were to subtract all of this, I would end up getting 0 equals 0. So what I have to ask myself is that a true statement? Okay. If it is, then that leads into one of those special solutions we actually had back when we were solving regular equations, where we said the answer was all real numbers. Okay. Here's why that's true. If I get rid of all of this, why I have an all real numbers solution is because when I actually go through and I show this graph, the graphs are, or the lines are exactly the same. So if I show this blue line, it's now overlapping and intersecting the red line at every single point. That's what we call a coinciding line because the lines are exactly the same. Okay. So there's your brief little example of coinciding. Now we're going to take a look over to parallel. Okay, so now let's look at parallel lines. Okay, so now I graphed, here's the first system, negative 3x plus 4y equals 16. Okay, and if I was trying to eliminate or use a linear combination, I would look and say, all right, well, can I get either my x's or y's to be together? And if you look here, if you wanted to make the y's the exact same, you would multiply both by 3. Okay, so if you multiply that top system by 3, you would notice that you would get almost identical, the exact same equation. Here's the difference, though. You still get a negative 9x. You still get a positive 12y. The problem is when you multiply 16 by 3, you actually don't get 64. Okay? So you end up getting 48 in that regard. So then when you subtract in the end, you end up getting 0 is equal to 16, which we know is not a true statement. That's what we call the false statement, meaning we had no solutions. So here's why you would have no solutions. Essentially, in every equation that you have, no solutions implies that there are no numbers that are going to make it a true statement, because in reality, you are solving equations to find out where two lines intersect. So where we had coinciding lines, they intersected at every single number. What type of lines do I have here? If I actually show this line, now I actually have parallel lines. So when I have parallel lines, the answers, there will be no intersection point because they physically have the same slope, but a different y-intercept. Okay, so just a brief overview. All real numbers is when we have the coinciding lines. When we have no solutions, that's where we have the parallel lines. I'm just going to write parallel for a quick statement. Okay. So now you guys can start going through some of the lesson. All right. And let us know if you have any other questions.